Right, so we know in the new style exams that there tends to be a lot of these questions where there's lots of information and sometimes you're not sure what to do with it or how to get through a particular mathematical problem you're facing. So I've come up with this acronym UWHAT, and it's a way of thinking through these problems. So the U, basically, it's telling you to look for key information, look for trigger words, look for that kind of thing that gives you a hint about what the question might be about. Once you've underlined something, then you've underlined it because it's important, so there's usually something that you know about it. So what do I know already from those words? If I'm not sure what's going on, I can always look to help myself. So things that you could do to help yourself is quite often drawing a diagram for worded questions could help. If there's already a diagram, add lines to the pictures, add information to those pictures, change the orientation. There's no reason why you can't turn the exam papers around so that you can look at things in different ways. If you don't know something, call it X, and usually if you call something X, it means you're going to create an equation to solve it and find the value of that letter. Obviously at the end of the day you've got to answer the question, so the A in the UWHAT is all about answering the question itself. The T is to test out your answer. Quite often you've done a lot of work, 4 or 5 mark questions, and you just want to test it out. Does your answer make sense? Does it seem reasonable in the context of the question? And if it's algebra in particular, quite often if you found a value for X, put it back into the equations and check they actually work. And the question mark at the end of the UWHAT is literally something I think is useful, is just to go back through ticking off every sentence in a question to just check have I actually done everything that the question wanted, because sometimes students miss marks because you know, the question said do you agree, or do you agree with John, or whatever, and the students forget to put the yes or yes I agree or the explain answers. You know, if it says give reasons, they sometimes forget to give the reasons. They do calculations, but they don't give the actual reasons, which are written words. So let's look at a couple of examples to see how this works. So here's a GCSE exam question. So we're going to follow the principle. So the first thing we're going to do is look for keywords and underline them. And if we're underlining something, it's because we know something about that information, and we'll be thinking about what do we know about it. Okay, so it's telling us that the shape ABCD is a trapezium. Well, straight away we know a trapezium has the properties of parallel sides for a 4-sided shape, 1 pair of parallel sides. So we can see in this shape then, add things to the diagrams, the H, help yourself. We know that these two are parallel. If that's true, then we know that's a right angle as well. So again, we're adding things to the picture that may help us eventually. So that's what that's telling us. So we go through, that's just information, just information, just information. It's telling us the angle ABC equals angle BCD. So yep, so they've already confirmed that those two angles are 90 degrees. It wants you to calculate the length, so we know that we're dealing with lengths, so that's either centimetres, metres, that kind of thing. And it wants AC. So we should be adding that onto the diagram so that we can see what is the actual length they want. So they want this length going all the way down here. So that's the length we actually want to identify. So we can see that ABC is a right angle triangle, and we go through this idea of what do we know about right angle triangles. Well, if we've got right angle triangles and lengths, then we know that we're dealing with this idea of Pythagoras, so or trigonometry, trigonometric ratios. We don't have any other angles at the moment apart from the right angle, so it's more likely to be, let's see if we can use Pythagoras. Well, we can see if we sketch out the triangle that we know that that's 9 centimetres. And what we'd ideally like to know is this length, and then we could work out this length, which is the AC that we want. So is there a way of doing that? Well, again, if we add things to the diagrams, the H, the help yourself, so we can help ourselves by adding things to the diagram, and we can see that if we add a line across here, then we have another right angle triangle because this line's parallel to this one, and we can see that that side is 10, and we know this bit is 3 centimetres, therefore this bit must be 6 centimetres. So we can see straight away here that we can get this line. So if we just call this E or something, then we can get the length of ED by using Pythagoras. So we can sketch out that triangle with the information we know. We know that's 6 and 10. the question is we want that, which we've defined as the length ED. And Pythagoras says, again, write things down to help yourself. So a squared plus b squared equals c squared, and we know from Pythagoras, because we should have a sketch of a picture to remind us what the letters mean. A, B and C are lengths, and C is always the hypotenuse, the one that is the length opposite the right angle. So we know this is C, we know we could label this A, and then this is B. So we have 6 squared plus b squared equals 10 squared. So 36 plus b squared equals 100. And so b squared, well, we'd have to subtract the 36, is 64. And then we know we want the length of b, so we remember to square root. And the square root of 64 is negative 8 or positive 8, but this is a length, so we'll only use the positive answer of 8 centimetres. So we now know the length of AD, so add things to the diagrams, help yourself all the time. And therefore this length must be the same. So we now know that that was 9 centimetres, we know this is 8 centimetres, and the question wanted the length of AC. So again we're using Pythagoras again. Won't write Pythagoras again because we've already got it over here, but we know that this time we want the length of the hypotenuse to be equivalent to the length of AC. So we have 8 squared plus 9 squared is equal to c squared, so 64 plus 81 is equal to c squared. 145, so 145, yep, c squared. So c equals the square root of 145. Okay, so we've got a calculator, and we're going to do the square root of 145. Okay, so it looks like we change it using that key there, so 12.04. So c is 12.04. We then go through, right, so we've answered the question. Now we test our answer. Does it seem reasonable? So 12.04, well, we'd expect from Pythagoras that the longest side is longer than the two of the short sides, which it is, so that seems reasonable. And it's not that much larger than the 9 and 8, because this is nearly an isosceles triangle, so that's fine as well. So we know that's probably okay. And then we go through ticking off have we done everything. So we recognise the trapezium, we've got all the information, that's fine, we've got the angle, we've calculated the length we wanted, and then it says give your answer to 3 significant figures. Okay, so we've just got that bit to do. 3 significant figures, find your first non-zero digit, so 1, and then we count from there. First significant figure, second significant figure, third significant figure, so we're going to cut the answer there. The hundredths is less than 5 hundredths, so the tenths stays as they are. So we can finally write down that AC has a length of 12 centimetres to 3 significant figures. Okay, so again, the UWHAT principle was about this idea of underlying key information. What do we know about it? And then we go through. So just do one more problem and see how that works. So let's have a look. So we've got a square. So straight away we ask ourselves, so we've underlined, and we ask ourselves, what does a square tell us? Well, it tells us that that length is equal to that length is equal to that length is equal to that length, and every angle is 90 degrees. Cut into 2 equal lengths, so we know these rectangles, we know that length is that, and we know that length is that, and so forth. Okay, so the perimeter of each rectangle is 24 centimetres. So we know the whole perimeter is 24 centimetres. Work out the area of the square. Okay, so a rectangle, what do we know about a rectangle? Well, we know that the opposite lengths are equal. And again, we know they have 90 degrees and so forth. Perimeter. Another key word, we know that means add up the edge lengths, so we add up the edge lengths of the shape. We don't actually know any of these lengths yet, so we're going to have to help ourselves. So we call something x, and as this question is about perimeter, it seems sensible to call one of the lengths x. So if we call the short side x, it says the perimeter of each rectangle is 24 centimetres. So, and we know that we've got 2 equal rectangles. So, well, actually it would be easier to call the whole length x, and then this would be a half x. The reason for that is we know this square, all the side lengths are the same, and so we know if we call that x, then this must be half of it because it's been cut in two equal rectangles. So that's going to be a half x. So this tells us then if I add up all of those, then I have 3x's, x plus x is 2x, plus 2 halves makes a whole, so that's 3 x's altogether. And the question told us the perimeter was 24 centimetres. So we know x, if we divide this through by 3, then we know x is 8 centimetres. So we know the square has a length of 8 centimetres by 8 centimetres. It says work out the area of the square, so we know that's a formula, so we can help ourselves by writing that down. So the area is the length times the length, or the height of the shape, but they're the same, so it's two lengths. So the area equals 8 times 8, which is 64 square centimetres. Always write units. I mean, I know in exam questions they tend to put the units down for you, but it's useful to do that. So we think we've answered the question. So now we've got to test it. Does my answer make sense? Does it seem reasonable? Well, if I said this was 8, I need to go back and put the 8 into the picture. And then this was a half of that, and that was a half of that. And then I've got to add these up and check that they do give me 24. Because that's what the question said, the perimeter should be 24. So 8 and 8 is 16, plus 4 is 20, plus so yeah, so that works out then. So we've checked that works. We recognise the square has been cut into two equal lengths. Yeah, we've checked that works, and we've worked out the area of the square. So we've gone through and ticked everything off to check that we've done everything. We've tested our answer, it seems reasonable by putting that information back in, and we've answered the question itself. Okay. So just one more then, so we can again see how the UWHAT principle could be applied. So the U, remind yourself, is underline key information. Basically you're looking for trigger words, words that should allow you to identify how to start the question. If you've underlined something, then it's asking myself, what do I know? Okay, so let's have a look. So we've got a diagram. We know it's a cuboid from the picture. The ratio of the length to the height to the depth of the cuboid is. So we've got a ratio going on. And it's telling us the total surface area is 4,950. So we can see surface area. Okay, so we don't know something. So we're going to help ourselves and call something x. So let's have a look. So that means we're going to end up creating equations. Okay, so the ratio of the length to the height to the depth is 1, so we might as well call the length x. Then we know the height is 2x, and we know the depth is 3x, because we're using the ratio to kind of help us. That was x, 2x, and 3x. We can see the question talks about surface area, so what do I know about surface area? Well, it's all the face areas of the shape added together. So, if I know this is a cuboid, then, because I've underlined that as key information, and we know that a cuboid is made with 6 faces. So again, what do we know about that? We know it's got 6 faces, and all of them are either squares or rectangles. So in this case they'll all be rectangles because the height, length and depth are all different. So we go through writing out those areas. So we can see that this one was 3x wide by 2x high. So the area of this one will be 2x times 3x, which is equal to 6x squared. We can see that the area of the front face here is x times 2x. So that's 2x squared. And we can see that the area of the top face here is going to be the length times the depth, so that's going to be x times 3x, so that's going to be 3x squared. And we know from the way cuboids work that the front area here is the same as the back area. The side area here is the same as the other side area, the opposite side, and the top and bottom are both opposite rectangles the same. So if we work out what these add up to and double it, that'll tell us the total surface area. So the total surface area is equal to twice 3x squared plus 6x squared plus 2x squared, 3, 9, 11, so 22x squared. And we know the total surface area because the question told us it was 4,950. So 4,950 equals 22x squared. So if we divide by 22, then x squared is going to equal. So 4,950 divide by 22 equals 225. Okay, so this looks like it was a non-calculated paper, so just remember if it was a non-calculated question, then you've got your method of doing division by using the bus stop as classically called. 22s into 49, 2 is 44, so that has a remainder of 5. 22s into 55 is 2 again, and that has 2 22s of 44, has a remainder of 11, and 22s into 110 is 5, so 225 again. So to get x we square root, so because we know the x squared value, so square root that and we get 15. So we know that x is worth 15 centimetres. So now we go through and see whether we've answered the question, because in UWHAT again we answer the question. And we can see here that find the length, height and depth of the cuboid. So go back in and write down what we know. We know that's 15 centimetres. We know this was 3x, so that means we've got 3 times 15, so that's 45 centimetres. And we know the height was 2x, so that's 2 times 15, which is equal to 30 centimetres. And of course we then write down the answer on the answer line. So height equals 30 centimetres, length equals 15 centimetres, and depth equals 45 centimetres. Okay, so now we test to see whether our answer is reasonable, and it said the ratio was the length to the height to the depth, so length to height to depth, so the length was 15, the height was 30, and the depth was 45. And if we simplify this ratio down, then we can divide all of these by 15, so 1 to 2 to 3. So yeah, that seems reasonable because that's what they said the ratio should be. We could go back through and put in all our x values and work out the surface areas and add them all up to get 4,950, but I think there's enough here to show us that we're probably okay. Alright, so we've gone through, so now we go through tick off. Have we done everything the question wanted? So the ratio, yeah, we've done that. We've dealt with that. We've dealt with the surface area. Have we found the length? Yeah, we have. So we're quite happy we've answered the question expected of us. Alright, so that's the UWHAT principle, guys. So hopefully you'll find using it, and I will mention it in other videos that I use to help you get ready for your exams. Hope it's of use.